Can you believe it? We are ready to talk about some derivatives today. Specifically, we're going to focus on this real nice introduction where derivative simply means what is the slope of the curve at this particular point. So basically some definitions that we can get in our notebooks. And if nothing else, we're going to be doing a lot of vocabulary here today. A derivative measures the instantaneous rate of change at a specific point. And again, that's a little different than average rate of change. So now we're focusing on instantaneous rate of change. We're picking one specific point on that graph, and we're saying at this split second, what is the slope of the curve? It's like, imagine a race car starting from scratch. It's at a dead stop. The green flag goes and it accelerates and it continues to gain speed. Gradually. What if you hit the pause button and said, okay, freeze it right now. What is the speed of the car right now? And that's kind of what we're doing. And we're just using the word slope instead of speed. Or another way to say derivative is it measures the steepness or it measures the slope at a specific point. So for a visual reference here, when we give you a specific point, just try to visualize a tangent line being drawn at that point. And the slope of that tangent line helps us identify or estimate what the derivative could be at that point. So in a nutshell, anytime this gets confusing, just replace the word derivative with slope and you'll never go wrong. Okay, so here's a couple of pictures of tangent lines. We picked a specific point. We said, hey, what's the derivative at this point? So what we tried to do is we tried to draw a tangent line, and the slope of that tangent line is going to tell us the instantaneous slope at that point. They're one and the same thing. Now, without the actual grid, it's hard to tell what the rise and run are. Because remember, all slope really is the ratio of the graph's vertical change compared to its horizontal change over that interval. And here's another really fun example. Here's a particular point. We want the derivative at that point. So we try to draw this tangent line, and it just skims the curve, right? Now, you'll notice there is another intersection over here, but we're kind of ignoring that. We're just saying, okay, remember, we're like within a neighborhood. Within this neighborhood, we only have one intersection. It just skims the outside edge of that graph. All right, let's dive in. Okay. First of all, notation. This is something, I don't know if, hopefully you can see this. There is like what looks like maybe a little apostrophe right there. This right here is read as F prime of 3. So when you see that little apostrophe, we read it as a prime, but basically it just means the derivative. So when you see F prime of 3, we're saying the derivative of f of x at 3. Another way to say that is to say the slope of the tangent line at x equals 3. Or another way yet, just in case you wanted one more way to say it, we could say the instantaneous rate of change of f at x equals 3. Now, I don't give you 3 variations here to try to confuse you. Really what I'm trying to do is we're trying to expose you to all the different ways that they could word questions so that we're prepared for however they may choose to word it on the AP exam. Okay, so we've got ourselves a really fun function. They didn't tell us the equation, and that's okay. In this question, we don't even care what the equation is. We're going to try to estimate the following values. And again, estimate. We're just looking for ballpark numbers. If I said the answer is positive 3 and you said 3.5, we're okay. But if I had positive 3 and you had negative 2, now we got a big problem. So the first one, and the prime signs kind of blend in with the F. So when you're writing these in your notebook, this is they're supposed to be like one of those apostrophes there. So this should say F prime of negative 2. In other words, we want the value of the derivative of f at x equals negative 2. So we're looking at this particular point right here, and I'm going to do my very, very best to draw a tangent line. Let's see. Okay, so I tried to draw this cute little pink tangent line, and how do I get this off there? Okay, maybe that'll do. So, and I just tried to skim the graph the best I could. And what I'm seeing here is I'm gonna say I'm really close to going through the point -1, 3 right there. So I'm just gonna estimate the slope right there between those 2 points, and it looks like I'm going up 3 units every time we run 1 unit. So I think the slope's going to be approximately 3. And again, it's a positive 3 because we're going up and to the right, or the tangent line is running uphill. The next one we want to try to estimate is this. Again, there's an apostrophe right there, so it says f prime of 0. So we want the slope at 0. Again, I'm going to try to draw a tangent line. Hopefully we don't butcher this. We're going to go skim it right there, in that neighborhood. We'll extend it as long as we dare. So let's just kind of see what kind of run we've got. This is a much tougher one to estimate here. We'll use this color. So let's see if we can pick out, maybe. Of course, I'm starting in the middle of a block right there. Looks like my run is a 1, and it looks like my rise might be a -1. So we can say roughly it looks like the slope is going to be a -1. We just got to make sure, like when it's supposed to be positive, we get positive. When it's supposed to be negative, we get negative. And then we can kind of, we're not going to split hairs over whether, if you had -2, you're certainly going to get credit on this one. And I think the way the homework's set up is that they're multiple choice questions, and the different choices you have are spread out far enough that you won't be tempted to go with 2 different choices. It'll be really clear cut which one they're looking at. The last one we want to look at, and this is a very, very interesting one, is f prime of 2.8. Now, why 2.8? Well, I tried to ballpark where the vertex or the turning point was, and I said that this turning point was occurring at 2.8 because I really wanted to zoom in. Oh, my goodness. Okay, I really wanted to zoom in on this point right here. This is what we call a relative min. It's the point on the graph where the curve changes from decreasing to increasing. And so there's something really special right there. The tangent line is going to be perfectly horizontal. Okay, so if I draw a tangent line, it's going to be perfectly horizontal, and it has a slope of 0. So, and as we go forward, having a slope of 0 is going to be really, really, really important for us to identify. There's another point. This point right here would also have a slope of 0. So there's going to come to a point where we're going to ask you, what do all relative maxes and all relative minimums have in common? And we would say, well, they all must have a slope of 0, or what we call a horizontal tangent line. All right, one other exercise here, and we're going to try to rank these 3 different values from smallest to biggest. So we're going to try to find the derivative, because again, that's an f prime. We're going to try to find the derivative at -1, the derivative at 0, the derivative at 2, or at least eyeball them to see who's biggest and who's smallest. So let's just eyeball these real fast. The derivative at -1, ooh, that looks kind of fun. It looks like we've got ourselves a turning point right here at -1. So I would say the tangent line is going to be horizontal, and the slope is 0, as we just discussed. So I'm going to make a little note that I think the slope is 0 right there. Now, when I get to x equals 0, so now I'm on this one right here. I'm going to try to find the derivative at x equals 0. What I notice right here, so this is the point that I'm looking at, right? And if I draw a tangent line, let me see if I can make these tangent lines a little thicker. All right, let's see. This is going to be a very steep line. Okay. Oh, this is a very interesting one because you'll notice half of my tangent line, this half lies below the curve slightly. This half lies above the curve slightly. And there's something really, really, really special about that point on the graph that we'll discuss in a later video, because usually what's normally going to happen if you go back and look at some of our earlier examples is the tangent line either lies entirely below the curve or it lies entirely above the curve. And the fact that this tangent line kind of lives half above and half below is really special. But what we notice about that line is it's very positive, if nothing else. And it looks like the slope could be in the ballpark of, maybe a +4. But just by making a note that it's positive is going to help us answer this question. Okay, it's a positive, and I'm going to say approximately 4. Now, the last one we're trying to get our hands on is this f prime of 2. What is the slope at 2? So here's my point right here. If I threw a tangent line on there, let's see if I could do this. Okay, so we're kind of in that neighborhood right there. I'm going to say the slope's about -3/2 or -1.5 would be my best estimate. But the bottom line is it's negative, right? We all agree that this line's going downhill. So we've got negative, and I said about -3/2 would be one of my better guesses. Okay, so let's rank them, right? So the smallest one's going to be f prime of 2. So I think the way that we're going to do it on our homework tonight, let's see, what happened to black? I totally lost black. All right, let's go with purple. So I'm going to say f prime of 2 is my first one. F prime of 2, and then I'm going to say less than, and then I'm going to say f prime of 1 because that was 0, and then I'll say f prime of 0. Oh, that's a prime. So I'm ranking them. Smallest was a negative, this was 0, this was positive. So anytime you've got one answer negative, one answer is positive, and the other answer is 0, it's really easy to rank them from smallest to biggest.